trying to have a garden. You're actually just trying to work with soil. So this is foundational, really exciting stuff. We will basically be with John up until about 12, and then we'll do a little bit of review of a cool tool that we all have access to called the Plant Toolbox, just so you can see how that works. But Dr. Havlin is an absolutely amazing presenter. He is so much fun. You teach a whole bunch of classes over at State, right? He is our go-to guy, right? Like when we have soil questions, we go to Dr. Havlin. So we are in great hands today, and with that, I will just turn it over to you.
Good morning. No, that's not needed. We're all good. Wait till it's over and see how you liked it. I don't know.
That's not gonna be nice now.
Let me just start out by saying it's really a pleasure for me to be here and interact with all of you. This is so important a topic for what you're doing that when you went through K through 12, I know it was a long time ago for most of you, some of you not so much, but they don't talk about soil science. They don't talk about soils. Now, earth science is in the curriculum, most places, school districts in the United States, but they don't really talk about soils when they talk about earth science. So we have this whole population of adults, various generations obviously, the more recent generations, the worse knowledge they have, the least knowledge they have about it. That you can talk to a group of 20-year-olds and ask them, well, okay, how many of you want to grow a garden someday? Most of them will raise their hand. That sounds like fun. How many know how to do it? No hands. And the key part is, as you all know, is that you just can't decide, I'm going to take this 1,000 square foot spot over here, that's 10 by 100, in case you're math challenged. And many of your youngins are these days because they don't do math very well in school. Just a quick story, during the COVID thing, I had my grandson 4 days a week. And he was 4 when that hit. He's 6 now, going on 7 here in a few months. So I had him 4 days a week. His parents kept working. They didn't have to stay home, so they were working. So he went to grandpa school. And the motto of grandpa school, I made him a certificate when he finished and all this other work, learn, play every day, you know. Well, he knew how to add and subtract 4-digit numbers by the time he was going to kindergarten. And in kindergarten, what did they do? Add and subtract numbers? They traced 1 through 10. He gets to first grade. Now he can do 10 minus x equals 3. What's x? To work on the math, on the adding and subtracting that way, kind of beginning steps of algebra. We're working on the multiplication tables as well. First grade, adding and subtracting single-digit numbers. So they're not getting what most of you got. They're diluting the program out, and that's a challenge. When you get that 1,000 square feet, you decide I want to grow sweet corn. You just don't go put the seed in the ground, dig a hole, put the seed in the ground, put some dirt on top of it, put a little water there, and walk away and expect out of that 1,000 square feet to have 10 bushels of sweet corn. Not going to happen. Not going to happen. You might get 1 or 2, and that's disappointing. And the question is, well, why didn't I get the 10 bushels that I should have got? And it's because you didn't understand what was going on in that soil. And that plant wasn't very healthy as a result of what was happening in that soil. You didn't do anything with that soil, you bought it that way. And it was that way for millennia, the soils in North Carolina, as you'll find out very soon. But before we get into all of that, I need to kind of get an assessment. How many of you are just backyard, landscape areas, shrubs and flowers and all that? Raise your hand if that's your direction, okay? How many of you are more up to larger land areas, as 1,000 square feet, gardens, where you're trying to go, okay, that's even more of you. Anybody larger acreage, like 5 or 6 or 10 or whatever? Excellent, excellent. This material is important to all of you, but Some of you that are working on little flower beds and so forth, some of it may not be all that pertinent because a lot of those areas are highly disturbed, if you will. You're up against construction sites, and that's not the original soil that was there, or they removed the topsoil. Actually, there wasn't much topsoil around when we started building because we took the trees down to build cities in the Northeast and the East Coast, right? And then they started growing cotton and tobacco and so forth. We're talking 200 or 300 years ago, yes? With very bad management practices. And most of the topsoils have long washed away due to water erosion. So most of our farmland today, they're farming what we call subsoil. You'll see that here in a minute. And that organic matter rich, even though it's thinner in our soils because of climate and other soil forming factors, than compared to Iowa, which has topsoil that can be that thick. And some of that's eroded as well. So we start out a little weak on the soil organic matter side, but the purpose of today is to talk about soil and how it varies on the landscape, what soil properties are important to keep in mind, kind of understand the language, if you will, make sure we understand the difference between soil texture and structure, and then how does water behave? Water is one of the most frequently limiting factors to optimum plant health, too much or too little. So we need to kind of understand soil water. And then when we get done with that, we're going to talk about soil health, which is this huge umbrella. But mostly when you hear that word phrase soil health, the thing you need to just immediately think about is organic matter. How do I get my organic matter content up so that maybe I don't need to apply too many nutrients? My soil is providing sufficient amount for whatever I'm trying to grow. That's pretty cool. And then after that, in order to make the 10, 20 bushels of sweet corn instead of 1 or 2, I got to find out, well, what was the problem? So I need the soil sample. I got to send it to a lab. I got a soil analysis report. And I had to see all those numbers and I go, oh my God, what the heck does this mean? So when you walk out of here today, you'll have a pretty good understanding of what all those parameters mean, how to interpret them. Now, as human brains work in terms of learning things, 6 to 8 weeks from now, if you don't look at it again, it's 80% of it's gone. But if you keep your notes and so forth and so on, you can bring it back and it comes back to you. For example, I'm from Chicago, South Side, and not a lot of ag there, right? Anyway, I farmed my in-laws' farm after college, and that's where I got interested in ag, and in college I got interested in soils and so forth. Chemistry major, and anyway I went to college, grad school. After farming 5 years, I went to grad school, and then here I am. Anyway, when one looks at that soil sample, there's a lot of parameters, and they're very confusing at first. So you won't remember all of those and all the relationships between them forever, but you have an extremely valuable resource sitting right here. And treat her well, be nice, because she does have a PhD, right? She's in high demand. And if you want to keep her here, then share the wealth. Anyway, you get my point, is you got a really valuable resource in this county. Many of the staff here are very valuable for you folks, so please. And when you get to the last slide here, I didn't put it on your handout because it saved me one extra page of printing. But my contact information, cell phone and email address was provided. And you go, "God, you gotta give me a cell phone, really?" I give all my students my cell phone. And the only hic about that is that when you first call me, I'm not gonna answer. Because I don't know what the number is. I don't know where that's coming from. So usually it's a sales, somebody's wanting to pay off my student loans. I love that one. I said, "Yeah, I got $100,000 still on there." I said, "Bring that check over here." Anyway, so please just leave a message, and I'll call you right back. And that's 7 days a week. That doesn't matter to me. That's why I tell my students, 7 a.m. to 11 p.m. After 11 p.m., you're not going to get a lot of intelligent responses. But okay, are we ready? You have the handouts, ma'am.
Yes, is that J.L. Havlin?
Yes, that's an L. Yes,
Okay, great, thank you.
that's an L.
Thank you.
Okay. Let's see. Soil science. Have you ever thought that soils and diversity would be in the same breath? Sorry, I missed. There it is. I flipped by. They are highly diverse on the planet. Highly diverse. You know, plants, animals have a nomenclature system, genus, species. That's how we scientific name things on the planet. We have the same system in soils, except these are called soil orders. There's 12 of them around the planet. And as you'll soon see, that in North Carolina, although this young, brilliant lady over here said to me, "Do you know we have alpha sols in North Carolina?" I said, "I had no idea." Learn something every day. Mostly we are these altasols here. And you know when you're working with one, it's red clay. Native Americans used to use this clay as dye. And so if you really want a pink or light red t-shirt, why just put some of that in the wash machine and you'll come out with a red t-shirt. But if you're working in the garden in a white t-shirt and you're doing this thing, you know you're going to have red everywhere. But they're very important to kind of understand some of these. This is the alpha sol you mentioned, and it's generally formed in forested areas of high rainfall. This is no rainfall. This is the Midwest where most of the ag is. They are the most productive soil order on the planet. If your country has a lot of mollisols and the climate to match, usually it is, your agriculture is usually pretty strong. So there's a reason why U.S. agriculture is one of the strongest on the planet, is because of the natural resource. Also, we had a lot of free enterprise going on that helped. But when you go to landscape, they vary. These are all altasols, but there's subtle differences between them that cause soil scientists to say this is a sisal clay loam and this is an appling sandy clay loam. A little bit different, but they're all related. They're all altasols, and if you have a larger piece of land than your little landscape areas around your home, you'll see those variations. If you're doing the landscape thing around the highs, those are highly disturbed, but down deep, you'll find the properties are the same as they were before they got disturbed. So, just keep in mind, if you wanted to know what kind of soil you have, this resource here that's got the soil survey manual sitting here in this office, and she can identify where your property is and what's going on. So again, every soil we call has a profile. Now, if you're in a raised bed, it's highly disturbed, yes? To a good way. Just like a golf green is not just sand, it's highly manufactured soil, 12 to 18 inches on a golf green. But we generally identify this surface area, and it varies in depth. Iowa, it's a lot deeper, called the A horizon. O and A horizon. The O horizon is something that's just old, dead residues that are on the soil surface. Little soil mixed in, but not much. So that's mostly decaying residue. All of these, if you find a farm field, go out to the countryside and find a farm field, these O and A's are gone, generally. But when you see this, you see that there's high organic matter, which means they hold a lot of water and they hold a lot of nutrients. And so plants remove that water and those nutrients in high amounts as well, because that's where they are. And a lot of roots are concentrated in the soil surface. So if I want my soil to provide more water, so I don't have to irrigate so often, and I don't want to buy and apply nutrients as frequently, then I got to increase soil organic matter. We'll spend a lot of time talking about that. We call that topsoil. So you've heard that phrase before, topsoil. That's the site, that's the material that we sample with the soil probe and send to the lab. And again, when you send that to the lab, make sure you follow the instructions. If it's cultivated, like a lot of gardens are, 0 to 8 inches is your sampling depth. And why is that important? Because the recommendations, the nutrient recommendations, are based on that sampling depth. And the distribution of nutrients in soils goes from much higher in the surface and much lower in the subsurface. So if you sample deeper than the recommended area, then the soil test value will be lower because you're mixing less nutrient-laden soil into that average, and the recommendation will be higher. If you sample shallower than the recommended, then the nutrient soil test value will be higher, and the recommendation will be a lot lower. So for turf, for example, it's 0 to 4 inches. So if you're doing your yard or your lawn, why it's 0 to 4 inches. And make sure when you pull the sample, I don't spend a lot of time talking about this today, but you make sure that thatch layer is removed. Any idea why we want to do that?
The thatch? Like,
Yes.
no, I do not know.
Well, you can see it right here. Where do the nutrients in this residue up here, if you just assume this is fescue yard or Bermuda grass or whatever it is, where do those nutrients in that leaf come from? Soil, right? And those roots go all the way down, right?
All right, yeah.
And so they're picking up nutrients from the entire rooting depth. And those nutrients are going up and being concentrated here. Now we leave the roots behind, of course, but the dead just think about how these soils develop. Over millennia, you got nutrients going up, being deposited at the surface. Going up the next year, deposited on the surface. Times a million years, why nutrients and organic matter accumulate in the surface and are less down here. So sometimes if I can go below the typical rooting depth of the native vegetation, sometimes nutrient levels are a little higher because the roots didn't get down that deep to pull those nutrients out. Anyway, just a minor item. When I get to the next couple horizons, this is the B horizon, and notice the organic matter content went down and the clay content went up. So there's very little organic matter. So there's very low nutrients, because I said I just pointed out the nutrient content is down on the surface. But clays do hold a lot of water. And so if I'm trying to avoid drought in the summer, and I'm not under irrigation, and this dries out, I want some roots down here taking up water in the lower depths that can carry that plant through the summer. Farmers understand, the producers understand this quite well. And what we want to do during the non-crop period for growers is make sure during when it rains, as much, and we'll talk about this here in a minute, as much of the water that comes in infiltrates and moves down and gets stored down here and doesn't run off. Well, water, when it hits the soil surface, has two choices. Either runs off or infiltrates. And we want most of it to infiltrate. Because if it runs off, it's going to take soil on top with it, which we don't want. So we'll talk about all those things. Anyway, down below is the evidence of material that the above soil might have been formed from, but a lot of soils in North Carolina are moved around from other areas by water, mostly, called alluvial soils, alluvial materials. And they're highly variable, depending upon where the water came from. So you can go in Wake County, for example, and it's mostly clay soils. But you can go near a stream bed, and you go 100 feet or so either side of the stream bed, and it's sandy. Sandy soils. I mean, almost like beach sand. And it's because as millennia ago, when not 20, 30,000 years ago, when the surface water was higher, it moved rapidly, a lot of material, and it moved so fast that only particles that fell through the water, came out of that water were the heavy ones, the sand. The clays were suspended and downstream. So we can walk over 300 feet, and you're in sandy soil, and then right 300 feet over here, it's heavy clay. And that is just the diversity that we see. So, again, topography of a landscape has a huge influence of the kind of soil that you're dealing with. This is bottom ground, and that's a hillside or hilltop. And notice how dark and organic rich this is, and not so much on the hillside. So any idea why that is? Erosion is one possibility. Definitely. But remember, these soils were covered in the virgin state before we start tilling them. Once we start tilling, exposing the soil surface, then they start moving with runoff. When it rains, the water hits down here, yes, and it has two choices. It runs off or infiltrates. The steeper the slope, what is the proportion that runs off? Greater, right? Increases. So my net water during a rainfall event is much greater here than it is here. And as a result of that, over hundreds of thousands of years of soil development, more water, more plant growth, more carbon fixed, more carbon left behind, higher soil organic matter. So the richest, most productive soils are these bottom grounds. Now, I want to grow corn and green beans or sweet, whatever it is you want to grow on that bottom ground, because there's plenty of water, plenty of nutrients. But if I'm growing wine grapes, because that's your favorite fruit, I want to grow that on the hillside, because I want to stress that plant with less water and less nutrients, because if I stress that plant, the flavor compounds are concentrated in the grape skins, and I get a better wine product. So it's not that I can't use that slopey land, it's just I got to use it differently than anyway, South Carolina, sorry.
A quick question.
Yes.
So, I understand all that principle and that the richest soil area and places to grow will be down where it was in that field. But, of course, may not be on topic at all, but consider monocrops, and that people are not rotating the crops, or depending on what kind of crops they're growing, all of that, even though that may be the richest area over time, and it could be a short time or even a longer time, it's not gonna be the best place.
Very good.
To grow a lot of things.
Did you hear her comment? Wasn't really a question, but what does this say?
Question. 'Cause I love soil. Thank you, Dr. Hunt.
Now, we will talk about that when we get to soil health and soil organic matter.
Okay.
That issue, because that's very important. We've done two things to degrade soil productivity. Two things to degrade, I missed that.
How many stickers do you have?
Oh, I got it. I'm encouraging you to raise hand, that's what I'm trying to do here. You haven't picked up on that. Okay.
Well, I have a question then. I was gonna save it till the end, but I wanted to ask, like, if on the clay soils, you're saying it holds water, it's good to have roots down there. When you've got a new bed, is it better to keep that intact,
Yeah.
or is it better to till it?
Keep it intact.
Keep it
Yeah.
intact.
Try to get organic matter and things up on surface so that water will infiltrate. Now it will fill up, If water doesn't percolate through that heavy clay layer, it's like a barrier, like this tabletop.
Yeah.
And so that can fill up and you get saturated soils,
Right.
and your saturated organic rich soil. You don't want to do that. So that still needs to be relatively well drained, but over time, let's just say I take a road grader or a big heavy dump truck and run over clay, just like this tabletop. Then I put a foot of organic rich topsoil on top, manufactured, and grow in a garden. Well, the first few years, why that water's not going to percolate. It's going to hit that clay layer and not move down. But eventually, as roots start to grow through that, eventually it'll start to loosen up and water will start to move through. But to fix that soil, it takes more than just one season.
Oh, boy.
Okay. So I wanted to point out, this is the soil that we have dominantly in North Carolina, and obviously we have a little alpha sol inclusion in here, but this is North Carolina. These are mountain soils. They're relatively young soils, not fresh parent material, but this is typical of highly weathered soil. When I say highly weathered soils, that means these rocks, before soil was formed, are sitting under a climate that has lots of water and pretty high temperatures. Can you think of another environment besides southeast U.S. that is hotter and wetter? The rainforest, equatorial regions. And they are the most weathered soil, called oxasalts. And they have pHs of 3.5. Ours natively are usually 5 or so or less. So we have some challenges with these altasols because they're highly weathered, but they can be very productive because we do have lots of rainfall and a long growing season. It's just how we manage them that's the key. So why are soils highly weathered in North Carolina? Well, this is just a rainfall distribution map, and we get 100 inches of rainfall in some of these areas, and 50 or so here. And so there's a lot of rainfall that moves through, yes? Infiltrates. And these are acid soils. This is pH right here. The dark is the lower pH, the lighter is higher pH. So we have 50, 60 inches of rainfall here, and we got 10 to 20 here. So there's 5 times the rainfall. So when you think about what's in the rain over the hundreds of thousands of years of development, we have a pH of rainfall that's 5.7. Did you know that? Unpolluted. Now your rainfall here has got about a pH unit lower than that because it's polluted. We'll talk about that here in a quick second. And the reason why it's a low, slightly acid is because of that reaction. Now, I'm going to show, obviously, you can't understand soils if you don't have some rudimentary, foundational understanding of a little bit of chemistry and a little bit of math. Most of you came out of K through 12 and other experiences with having that. And that's great. So, I don't feel that you don't know what that is. I think you do. What is that? Dihydrogen oxide, one of the most toxic chemicals on the planet, right? We should ban that.
Yeah.
And that's CO2. That's good too. That's a good compound in our planet, life on the planet. Okay. And when it combines with CO2 and water, we get a little hydrogen. So all water, rainfall, natural water has a slightly acidic pH. Well, that's very, very important for development of soils because that slight amount of acid now coats that rock, and that rock over time wets and dries and freezes and thaws, not freezes and thaws too much here, but weathering processes, breaks that rock up into smaller and smaller and smaller pieces. That increases the surface area, and so the acid has a greater chance of dissolving the compounds, the salts, the compounds that are in that rock. And so the cations and anions come out, and that's the soup that forms soil, is that weathering process. We could spend more time on that, which we don't have it. So I'm just gonna tell you the result of all that weathering process in the southeast is that we've had, because we get water that moves through, now it's clay, but it's pretty well fractured. The percolation, if you know what that word, we'll talk about it here in a minute, is pretty good in these heavy soils. They've got old root channels and they've got natural cracks that can transport water pretty well. But with all that water going in, and the reason why the pH is lower here than it is in Colorado is because at pH 5.7, both places, I get a liter of water. pH means the concentration of hydrogen per liter. How many of those hydrogen ions in a liter of water? Well, if I put 1 liter of water on, I get so many 10 to the minus 5 moles of hydrogen. But if I have 5 liters, I got 5 times the amount of hydrogen going in. And so my soils here are acid. So as a result of that, I accumulate this acid. You know what that is? Aluminum. So I have that in red. Keep a note of that because it will bring this back. I always put the bad guys in red and the good guys in blue. These are plant nutrients, essential plant nutrients. And we have some of those nutrients being moved out of the profile over hundreds of thousands of years. And as a result of that, the pH is lower. So we have acid soils. So when you go plant that field of sweet corn and don't do a soil sample, figure out what the pH is and how much, and the optimum pH for corn is 6, 6.5, you're not going to raise as much corn. And so we need to understand that we've got that problem. We also have soils here that are naturally low in phosphorus unless it's an old tobacco field or a field that has a history of animal waste application, which we have a lot of those. But if you're in the urban area, then it may have been an old tobacco field. And back 150 years ago, we knew about phosphorus back then, and they would have a product that they could apply, bone meal and all kinds of other things that elevated those P levels over time. Anyway, what we do notice in our ultrasols is infiltration rates are generally pretty low if we don't have that A horizon that's got a lot of dead roots and live roots to allow that water to move through. Act like straws. So we rarely have high runoff, but if it's fully tilled and no residue on the surface, then more water will run off and less will infiltrate. But down, once we get it in, you can kind of see those cracks in there. Water can move, and so when we get roots to go down in here, we can pick up a lot of water during low rainfall periods. But this business is one of the problems in agriculture in North Carolina, is because of these clays and a history of heavy machinery use over the last 100 years or so. We have compaction. It's the second most frequent reason why yields are lower than they could be in agriculture in North Carolina is because of compaction. But again, as I just mentioned, we can fix this, but it takes a decade to alleviate some of that compaction issue. All right, we'll come back to that. So, some basic soil science. You take a quart of soil out of your wherever, and that volume, 50% of that volume is sand, silt, or clay, solids, with some organic matter. And it varies quite a bit, but this is the life of the soil. This is what when we talk about soil health, we're going to focus on this. I cannot change the percentage of sand, silt, and clay in my soil or soil texture. Can't do that. I can do it in my raised bed. I can do it in my small garden. I can get somebody to give me a dump truck load of sand or mulch or compost or something and help. But I generally can't change soil texture. So the remaining 50% of that volume is pore space, the spaces between the sand, silt, clay particles. So you take a bucket and you fill it with ping pong balls, and there are spaces between the ping pong balls. That's the pore space. That's where water is, that's where the roots grow through, that's where the organisms are, that's where the life is. That's the action. So, again, texture, clay particles are minute, you can't see them, yes? If I take a clay soil and put some enough water, it feels greasy. Sandy feels gritty. I don't need you to understand that, but the sand particles are a lot bigger than the clay particles. And it influences a lot of properties and helps us to understand how water moves and behaves in soil. You may see this textural triangle. I'm not going to focus on it. It's how soil scientists classify textures when they classify soil, and they get a soil that has 100% clay. You don't want that. That'll compact, that's hard to work with. You don't want this, 100% sand. It doesn't hold any water, water goes right through, it's really hard to manage water. What you really want is something right in here. But when you buy a piece of property, I bet you didn't look at the soil survey manual first and find out what you were buying. So you get what you get, and then you gotta figure out how best to manage it. So again, you'll see these phrases in your soil survey manual that say a sandy loam. It just represents that a sandy loam has a lot more sand than the clay and the medium-sized particles. That's all it is. And then a clay soil has a lot of clay and less sand, etc. And so again, these textures are very highly variable in the landscape. Anybody like to drive to the ocean from here? Go down I-40, yes, towards Wilmington? Well, if you go down I-40, we got clay soils here. You go down I-40, go to exit 350. Don't pull off, but keep driving. You'll see center pivots and the farm fields either side. Center pivot irrigation. Those soils are sandy. Sandy soil is about 10 miles down the road. They're sandy soil. It's an old beachfront. Water ocean level used to be a lot higher a couple million years ago than it is today. And that's why that is. So, what are the properties that this texture influences? Now, I got a lot of words up here. I think most of you know these words. So, infiltration, what does that mean? You already got one. Somebody say it louder. Goes in. It goes into, I'm going to go over here. Pass that one back. So, infiltration's high. When you pour water on it, goes right through. I tease my students in I have this 100 level class. It's a gen ed course to try to elevate the knowledge of adults in America about soils, how important it is to life on the planet. Infiltration, percolation, runoff relationships. It's easy when you're at the, you like to go to the beach? Oh yeah, we like to go to the beach. Well, what do you take? An umbrella? Yeah, okay. Sunscreen? Yeah, okay, sunscreen. And then somebody goes, oh yeah, a cooler. Gotta have a cooler, right? What's in the cooler? Beer. Okay, I get it. And so you don't buy one of those little coolers. You get one of the substantial size. Let's put the 12-pack in there. Okay, and you've had 11 of them. And after the 11th beer, you grab that 12th one, and you got to take a walk to the ocean, right? Okay. And when you get down there after the 11 beers, you're not walking too straight, and so you fall over and you spill your beer on the beach, and what happens to it? So you can imagine a clay beach. I wouldn't want to go to a clay beach necessarily, but if you did the same thing on a clay beach, it would just run off into the ocean. It wouldn't. The infiltration rate is so slow in a clay soil. So you got to remember that when we're managing water, we're irrigating, that water doesn't go in very fast, and so I got to slow up the rate at which I'm applying the water. So runoff is the opposite. Runoff is high in a clay, low in a sand. Most of it infiltrates, not much of it runs off. Percolation is no different than infiltration, except infiltration is water going into the surface, percolation is moving it through the profile. So it's water, and again, percolation would be low in a clay, and high in the sand. Water holding capacity, we're gonna open this can of worms here real soon. That water holding capacity is high. That's how much water can be retained in these pores. It does not say a lot about how much of that is plant available. We have to distinguish that. To recognize that a clay soil will hold a lot of water, but there's a lot of it that my plant can't get, even though it's there. And then aeration, that makes some sense to big pores. Water goes right through, then air moves in and out readily. Okay. So this is the relation to water infiltration and runoff. It's very simple. The higher once I get a rainfall event beginning, I get high infiltration and no runoff, and then after the pores start filling up, then less water goes in and more water runs out. So when some of you remember 1999, the big flooding event, Tarboro and Princeton. Okay. I got here in '96. I left Kansas as faculty member there and came here as department head of soil science in '96. And so when that flood hit, you remember that we had 4 hurricanes that year, that summer, late summer, fall. And one of them, actually we only had 3, one of them hit us and then went up northeast, came back around and hit us again. And after those 4 events, why we had soils that were saturated. All the pores were filled with water, so the additional rainfall couldn't go anywhere else but accumulate and run off. And that's when the rivers flooded. And it was a surreal sight. I went after the water receded. It was 30 feet. The only thing left at Princeton was the little steeple, 30 feet of water. And driving through there after the water receded, when they let us back in, go check on some of our facilities out in those areas. Hogs and chickens stuck in tree branches 30 feet above you. That was welcome to North Carolina. Anyway, that was funny that when I moved here, remember Fran?
Yes.
96? Yes? I moved here the day before. So my second night, Fran hit. And Raleigh, of course, had 70 mile an hour winds and trees falling all over. Fortunately, the house we bought didn't have a tree hit. One of mine hit my neighbor's. He was not happy with me. But after that, everybody called me Hurricane Havlin. They thought I brought it with me. But here's the infiltration rate and time. This is just clay. You can see I got infiltrations a lot less than the sand. That's spilling the beer on the beach. And it doesn't take long for the pores to fill up, and away you go. That's the infiltration rate goes to 0. And when that happens, it's all runoff. And you don't get any of that water in your profile. So that's the challenge with the clay, and that's the challenge with the sand. That's why I say if you've got the choice, this is kind of the texture you're interested in. So let's just quantify this water. Take a microscope and look at a soil particle, clay particle in the soil. There it is. Okay, it has some charges. We're going to talk about those here a little bit. Negative charge, it has some positive charges, but water molecule is polar, right? You got the oxygen right here, you got the 2 little hydrogens set there, so it's polar. So it's got a positive end and a negative end, just like a magnet. And the positive end is attracted to the negative charge on the clay. So the water molecule sticks, and it's really stuck hard. A plant cannot suck that little layer, 1 molecule layer of water away from that clay. Doesn't have enough power to do it. The physics just doesn't work. So I can drive that off by taking the soil sample, putting it in an oven, drive that water out. Call that oven dry soil. We would not do that. But if I left it on my driveway, sample on my driveway, and just let nature take its course, I could let the heat and the sun drive that water out. That's called air dry soil. And that water's not, plant can't get that water. So there's 4 or 5 more molecules of water there, and the plant can't get that either. So that limit is called wilting point. You're familiar with that phrase, permanent wilting point. It's the content of the water below which my plant's not going to survive. Permanent wilting. It's the water content in the soil below which my plants can't get water. Even though there's water there, it just can't pull it away from those clay particles. And so as water then fills this up, then I get to the point where my pores are, got them all full, and then I stop irrigating or it stops raining and it drains just a little bit. And when it stops percolating, gravity no longer moves water down through percolation. We call that field capacity. That's a term not many are familiar with. That's the water content when most of the pores are full of water. There's some air, and so plants like field capacity. They get plenty of air. Plants need air in the soil to grow as well as water. And so the difference between that water content and that one before the plant wilts is plant available water. How much water is available to my plant to grow? So that's the definition of plant available water. And again, field capacity minus the content minus that is how many inches of available water I have. So we're not going to do it today. It's too much math today. I got many more things to cover. But I make my students do this. You know, we have fresh water issue coming the next couple decades. Some of us won't see it, but that's the next climate change crisis, is fresh water on the planet. And we waste a lot of fresh water. Just drive down the streets in Durham or wherever you are and it's raining and they got the sprinklers on. The city's got the sprinklers running. We need to be careful about that. 2007, we had one of the worst droughts in 150 years in North Carolina, and Falls Lake was about 1/3 of its water holding capacity. I mean, we used it. And what did most of that water go for? People, yes, but irrigation, golf courses, and so forth and so on. And it was almost below half by the time the county woke up and said, maybe we ought to restrict watering lawns. So they went every other day. You had an even address, you did Mondays and Thursdays, you had an odd, you remember that? Anyway. And then it got so bad they just said no more. Done. And that's what's going to happen. And the issue is that, gosh, you know what? I can take how much water my yard will use. I can look that up per growing season, how many total inches of water that fescue will transpire, and how much the soil will hold and then the plant uses it. And then when it gets down to here, it dies. The plant dies because I don't have enough water, right? So I got to fill it back up. Well, I got to irrigate. It's got to rain. So I estimate the average annual rainfall or monthly rainfall over that growing period. So I know how much water is being used, how much the soil will hold, how much rainfall I get, and do a simple water balance and find out, well, how much additional water do I need to apply to just keep my plant healthy, but not overwater. Not overwater. And if we did that, if everybody that was irrigating their yards and so forth did that, it would make a huge impact on Falls Lake and water resources for the rest of us.
So is there any thinking that like golf courses should be required to do that? You know, is there any legislation moving forward?
Have you worked for the government before?
Long time ago.
I sensed it. Okay. Yes.
Well, I have a question about whether you can just tell that by cooling on the surface of your lawn.
Yes, of course you can. Yes, of course you
You're
can.
not
But
all gonna
the
figure out.
question is we can estimate how much additional area. Now, if it rains more that summer than the previous summer, then I can make adjustments as we go along, no question. Or I'm estimating that this next 3 weeks I'm going to need to add some water, and all of a sudden it rains half that time period. Yeah, then I can make adjustments.
To actually hit it before.
But the other thing the other thing that we do now, and it's available today, a little more expensive, but we have now sensors. See what happens on these big mansions, not mansions, but big houses that have 2 or 3 acres and they water their fescue yard. They have a controller in the garage. And somebody sets the controller and they go, well, it's going to go on every 2 days and apply and run for 40 minutes. They don't know. It just goes on every 2. Now, usually there's a sensor up on your roof that says if it's raining, it won't turn on. But that little sensor is one of the first things that goes on with these systems, and if that sensor's not working, then it turns on and it's raining outside. The technology's coming though, it already exists, but it's just not as cost effective today, but it is in the next 5 years or less. A sensor in your yard, various places, and it's no wires connected, it's remote, and measures the soil water content, and when it gets down to permanent wilting point, the system will go on. The system will turn on, yes.
So how do I, if I'm trying to determine how much, if I heard you correctly, water or rainfall is actually happening in a year, I would look at the amount of rain that happened in Durham, and then, but how do I calculate that in relationship?
A good question. Every county has an average and monthly rainfall. Just look it up. That's average, 50-year average.
Yeah.
There's a big error bar around that average, right? So some years are dry, some years are wet. So it's a tough number to nail every single year based on 50-year averages, but it's better than what they're doing now, by far better.
But how does that apply to my particular yard? The topography of it could
Yeah.
be off, 'cause there's so many things involved.
Oh, absolutely, absolutely. It's not as simple as I'm making it sound, yes.
That's just not to have a lawn at all and just have, just natural fauna in the yard?
Yeah, it wouldn't matter what plants are there. Is that what your question is? Wouldn't matter really what plants are there? They all
well, just it seems like lawns require so much more, like a grass lawn.
They
requires
can, yes, they
more
can,
than
but
this.
again, when you look at water use of any plant,
Okay.
even the native plants, the water use is pretty high.
Okay.
Yes,
What,
no, I'm sorry, go ahead.
I'm sorry, what level does slope of the land become an issue for this not to work? I'm thinking of my own yard that it's very sloped.
And as soon,
And
sorry.
it all, everything is a runoff. There's,
Once you identify that I have a fine textured soil on that slope,
right,
you can figure 80% of that rainfalls. If you're over a half inch of rain, most of that water is gonna run.
right, so.
Nothing you can do other than bench terrace
Yeah.
that hillside
Yeah.
to slow that water runoff. And farmers are quite well aware of that. Let me just go through this water holding capacity. In this diagram, it just simply shows I've taken a cylinder of soil, 100 mils, okay? And I've filled each one, that's the sandy, that's spilling the beer on the beach, and that's the clay. I added 10 mils of water. And obviously all of it's going in, all of it's infiltrating. It wet the soil only to here, but in the sand it wet it all the way down to here. Why is that? Pore space. Go hand out a few of those, would you, don't duplicate. I don't want somebody to come out here with a white vest. Anyway. That's okay. Anyway. Very good. Excellent. There's more pores, so the water fills up those pores and can't go any further. So the clay particles are holding onto that water and preventing it from moving down. So if I wanted to fill up all the pores, this is the other way to look at it. It takes me 15 mils to fill them all up in a sand, but takes me almost 3 times as much to fill up all the pores in this clay. So clays hold much more water than the sand, and that's why sandy soils are more difficult to manage whatever it is you're trying to grow, because you have to water more frequently. Yes?
Just a quick question. Will all roots eventually get down to the clay, or are there some that just aren't because of the...
Good question. Can you hold that thought?
Oh.
No. That's a great question. I'm getting there. So, this is the diagram. Hang on a second. Let me get through this, and then I'll get to you. Sandy soil. Remember permanent wilting point, below which plants can't get any water? Field capacity, that's the maximum it'll hold after percolation stops. The difference is plant available water. So in the sand, I got a 1.2 inches, 1.3 inches, and here's 0.5, so I got less than an inch of plant available water in a foot of soil. Inches of water per foot of soil depth. Less than an inch. But over here, I got an inch and a half. But plant available water is still is greater here than it is in the clay. Even though the clay holds more total water, plant available water is still less in the clay than it is in one of these loam soils. So again, if I had a choice, that's what I would buy. But again, in your manufactured raised beds and so forth, you would like to have some clay mixed in with that organic rich material that you put on top so that you have more water holding capacity.
When you use a hygrometer, are you measuring plants available?
Yes,
Okay.
yes. Question back there, and
I was just wondering, what's the difference between loam and silt?
none.
Okay.
None. It's just a term we often use for the silt-sized particles. Loam is usually one of those terms that relates to, I don't want to go back in the interest of time. Loam is a term that represents a small, about a third percentage sand in my soil, a third percentage, 30% clay, and 30% silt. So silt is the size of the particle, loam is its soil texture, which includes all three. Anyway, so when you see this, when you have one of these three textures and anything in between, there's the thing we had up again in the sand. We have high infiltration, low water holding. And so if I want to maintain good healthy plants, I got to apply just a little. If I applied too much, what happens to the extra water? It moves down because it's building a beer on the beach. It goes right down, and my plant roots aren't going to get it unless I have deep rooting crops. So I got to apply a little bit of water very frequently. The opposite is here. This holds a lot of water, but it doesn't infiltrate very readily. So I still apply a little bit of water, maybe not as frequent as the sand, but I'm still applying it very small. And this is the question I raised earlier, was we're overwatering. We're overwatering. And by setting your timer to run for a half hour, 40 minutes, and you don't know how much water is being applied in that time period, I don't see any landscapers out there kind of calibrating that unit. They just look at the manual and go, oh, if I set it here, we get a half an inch of water an hour. I don't know. They don't measure it. There are ways to measure it and calibrate your system. Now, when I said we estimate total water use, that's over the growing season. And we recognize that I'm not going to apply, if I need 2 inches of water irrigation over rainfall and soil storage a month, most of that's going to be applied here and just a little bit here. So I've got to change the distribution. It's not equal distribution of irrigation. So that's the adjustment that you have to make at home. So, you know ET, right? I wanted to go through what the hydrology water balance is typically in North Carolina, and one of the parameters is ET. I want to make sure you understood that.
What is it?
Evapotranspiration. It is the combination of water moving through the plant roots, out of those soil pores into the roots. And the reason why it moves up is because the pressure is so negative. There's not much water in the air, and there's a lot more water in the soil, and so there's negative pressure in the air compared to in the soil, and you have this straw. The physics says I got a straw, and it moves it up the stem and out the leaves. So I get water evaporating from the leaves, but that came from the soil. But I also have water in the soil that evaporates from around each plant. So total water use is the sum of water being transpired plus what's being evaporated around the plant. So if I want to reduce evaporation from the soil surface in my garden, I want to make sure I mulch those bare areas between my plants and between the rows, so that most of the water is then transpired and very little evaporated. And you know what happens when things get towards permanent wilting point. That's normal. That's headed towards permanent wilting point, and now that crop only has about 3 days left before things go really south. Okay, so typical county in eastern North Carolina, that's average rainfall. This is 50-year averages. Last year or this year or whatever year you want, it could be, whoops, sorry, I keep hitting the wrong button. It could be bounce all over the place. 50-year averages. Pretty consistent, isn't it? And that's ET. Does that make sense? Water use by the plant is a lot higher in the summer than it is early and late. Yes? So I have water demand by my plant that rainfall during that time period can't meet. So that plant has to have roots going down to find that extra water. That's why the infiltration, maintaining high infiltration rate is important. Yes, sir. Ma'am. Sir.
How do you all change it? What seems like it's changing is that 50-year average stays the same, but we get it 3 days of the month instead of 12.
Yeah, there's a lot of variability in the 50-year average. So it's difficult to make a decision in a given year based upon a 50-year average. You're right, it is. But it's the only thing we have. We can't predict how much we're going to get and when we're going to get it. So not being able to do that, and you can't rely on WRAL or whoever it is, the rainfall predictions, because they never hit it. So that's very difficult. Yes, you're correct. So when ET is high, my soil water should go down, right? Because my plant's using it. And notice I got lots of soil water out here because my rainfall is a lot greater than the plants use. So soil water builds up. And when water builds up and fills all the pores, then I get drainage. And some of you have situations where you got saturated soils today because it rained heavily. Yes, and you have no water use. But as soon as the sun comes out and the plants start growing, then you get water use, and you don't see saturated soils in July, do you? Unless you've over-irrigated. Yes, we can see them. All right, please understand that most of the water that we're using, and this gets to your question, I said, wait a minute, in the surface foot, but we want roots to go down, and don't overestimate how deep those roots will grow. I work with the wine grape growers. When I stopped being an administrator, which I hated, anyway, this is the part I love most is working with you folks, and growers would say, oh, grape plants up here, roots got to be at least that deep. Wine grape roots aren't any deeper than a couple feet. Now if I grew it in a pure sand, why they would grow that deep, but not in our soils. They're a couple feet. So that's really all the water that I have available to my plant, is that water that's in that surface soil. So there's us looking at roots in a vineyard to prove to growers that our roots aren't growing that deep. We just need to manage water, etc. But your question is, can roots grow down to get that water? Yeah, if you put the right plants, they can. But these guys aren't. Carrots, radishes, beets, right?
Tomatoes.
Tomatoes have actually a pretty good taproot kind of system. But it's not like sweet corn. It's not like green beans. But when any kind of tuberous crop like this, why it's very shallow rooted, and you're going to have to pay a lot more attention to water balance and potentially irrigate more frequently if it doesn't rain. If you're supposed to get 4 inches of rain that month, and it only rained a ½ inch so far, and it's it's July 20th, you're going to be short. Yes, sir.
So can you optimize your irrigation schedule to promote more root growth?
Yes.
Do you need to let the soil dry out between water cycles to some degree?
That's a very good question. Did you hear that?
Yeah.
Do I need to let the soil dry out? No, you don't need to let the soil dry out, but you have a wide range in water content between field capacity and permanent wilting. There's no problem with using the majority of that plant available water. Just be cognizant of water use per day is really high, and you get down here, it doesn't take many days to stress that plant, and then you've lost yield.
And as you move down in water capacity, will that actually stimulate roots to grow farther down?
Yes, yes it
Can you
can.
repeat that question, please,
The
sir?
question was, will that stimulate some roots to move down towards the water? The root growth is a lot related to the energy supply in the plant to feed that root to get it to grow, but that's its general physiology is to, and morphology is to grow and grow deeper and out. But a lot of times in North Carolina soils, we hit clay pans down a couple feet, and we also hit some very acidic layers, and roots don't like aluminum. That's the next topic. And so once they hit that high aluminum layer, you're kind of done. So we'll talk about that. Anyway, that's topic one. What time have we got there, Miss Ashley? There's the clock, I'm sorry.
No, you're good.
We're
We'll
good.
go about 10:30.
We're good. Let's get this one done. Any other questions on water? There was a couple, yes.
If you have standing water, after it rains heavy and it stands, say, more than 24 hours, is there a bigger issue, or you just have nothing but plain, you do?
If it
more
does
soil
for
and-
grow, if you have standing water, you have growing plants.
Mhm.
Most plants,
Don't like that.
30 to 75 hours,
Mhm.
you got problems.
Okay.
I know corn better than I do a lot of garden plants in this regard. But in 3 days, if you have a cornfield and you got a runoff area in the field and it's standing water, that plant is dead in 3 days.
So you bring more topsoil?
No, you try to figure out how to drain that area
Okay.
for the future, yeah.
Okay.
You can do that, but it's usually easier to figure out a way to shape the surface so that water doesn't accumulate in that hole and runs off.
If I understood Eric's question, in relationship to a plant having access to finally having access to the water if there's sufficient water. But you were talking about as the days go on and you know it's gonna get hotter and the temperature's changing. Were you saying it's better then to be just consistent, or in the early stages grow water more and, or maybe I'm completely off base?
No, the question is the timing of watering relative to
Yeah.
plant phenology or growth.
Yeah.
And you really want to make sure that you don't overwater early,
Right.
because you don't wanna, you want saturated, so you want those roots to be able, they gotta have air to be able to grow through.
Right.
Once they find saturated layer,
Yeah.
root growth is done, so
Yeah.
you don't want that. So it's best to just spoon feed it early.
Okay.
Generally, you don't need to be too worried early in the spring. Your soil profile is pretty full of water from the winter. Your plant growth ET is really low. Temperatures are low, right? So water use is pretty small. A seedling and early growth stage of your garden, of your plants. But as they start to grow, then the ET goes through the roof, and the soil water evaporation is increased because of air temperature, higher winds, and all those factors.
Thank you.
And then you gotta adjust. You gotta add more water.
Thank you.
Okay. Oops. So let's just globally think about soils. When humans first started going into communities and not hunting and gathering, they started growing crops. This was thousands of years ago. There's evidence 5,000 years before BC that Mesopotamia, they cultivated crops and irrigated. So, and we didn't have a lot of knowledge of water, soil, nutrients, and so forth and so on, and so those soils deteriorated. So these are the processes that cause soil to degrade And when you found a farm field and built a subdivision on it, that soil was already degraded. We lost the topsoil due to water erosion in North Carolina. Matter of fact, North Carolina's soil erosion was so massive, by 1930s, there was a big push for soil conservation, and Hugh Hammond Bennett, who's a native of North Carolina, Anson, North Carolina, his birthplace is on the National Historic Registry, was a soil scientist at NC State, worked for the federal government, and he was the one that pushed for legislation that created what's called the Soil Erosion Service in 1936. Soil erosion, which became the Soil Conservation Service, SCS, and now as we know that as the Natural Resource Conservation. And it was water erosion. Just look on USDA soil erosion, and then there's a link of photos, and you'll see some amazing photos. Those are the degrading processes, but we have technologies that can bring that health back. So basically, I've lost the A horizon, and now I gotta remanufacture that. The problem with this is that I can lose this in just a few years, and it might take a century to bring it back. You'll never see it the way it was in your lifetime. It's not gonna happen. Yes, you can make it happen in your raised bed and in the garden, yes you can, but in the farm fields, it's just not gonna happen. But we can move that direction. So again, the degradation that occurs is the erosion of that surface soil. That's a physical loss, but even if I didn't get runoff and move the soil particles off the field, just tilling it, stirring it up, bringing oxygen in, encourages the bacteria to grow more. They like a little more oxygen, and they start breaking down soil organic matter and oxidize some of that carbon, and we get loss. So, I can go around the planet, and a few places. I had the opportunity of working on these plots when I was at K-State. This is soil organic matter as a percent of the virgin soil, never been touched. So you don't notice percent organic matter, it's percent of the original. So 100%, whether it was 2% or 5%, doesn't matter. Within 50 years, I've lost half of it. 50 years. This is average value. Again, average rainfall, average values, it's all over the place. In a harsher environment, it only took 30 years. 50 years, I lost 70% of it, yes.
So how do you determine that? You don't wait 50 years to determine it, so how do you determine that?
I didn't.
How do you determine it's 50 years?
Yeah, you don't wait 50 years to do your experiment, so how do you determine that it took 50 years?
Oh yeah, these are definitely long-term plots.
So you collect a plot.
Yes,
I see
these are
what's
plots that were,
and then
yeah, very good, yes, they were plots that were established on virgin soils. There was one established in where I was at in western Nebraska for a while, and that's just north of these plots that were established in 1950. And anyway, Oregon has had plots since 1890. Australia is similar. So yeah, there are long-term plots that we well recognize these rates. So generically, this is what happens. You only have one slide of this. I've animated it a bit. And so here's my organic matter, virgin soil. And that organic matter, by the way, comes from the higher the rainfall, the more plant growth I get, the more carbon is fixed. So higher rainfall areas generally have greater organic matter. So Northwest is pretty high organic matter in those soils. Midwest, a lot higher organic matter. Now we have high rainfall here, but the temperatures are really high. And hot soil oxidizes carbon. And so it's challenged to get carbon to go up in North Carolina compared to doing the same amount of conservation practices in Iowa, for example. I can get a faster growth in soil organic matter there. But anyway, in 50 years, I've lost half of it. There's my 50-year point. Why did it, here's its level. That organic matter level is there because I have native vegetation and it fixes so much carbon in the atmosphere and leaves those leaves and roots, and it's a steady state. It's the same amount every year. So it doesn't change. Humans came in and screwed it up. They came in and they planted, I don't know, tobacco and cotton and whatever. They didn't produce much carbon. Very small residue crops. And then they tilled, so they got soil erosion going on and less carbon going in than the virgin species. So I have two things. I have less carbon going in and I got a lot of carbon going out from erosion. It's steady down here because my erosion is constant, and I've changed the rotation, and now my carbon input is leveled off and is constant again, but constant at a lower level, so my organic matter dropped. So what do I need to get it to come back? I need to stop tilling, and I need to change my crops that I plant that produces more vegetation, fixes more carbon, I leave that behind. So I got to change my rotation. So I adopt no-till, that's the NT, and other best management practices. We're not going to go through them all today. But the other one is some of those BMPs now that we're in North Carolina, cover cropping. This is very important. And if you don't like the rate of increase of soil organic matter, working on a piece of land for 10 years, why then import more carbon than the rotation will produce. You got to go buy some carbon. That's compost, sawdust, I don't care what it is, as long as you can get it in there and find enough particle size to incorporate, have the bacteria degrade it, and don't go buy compost or anything else organic unless you have a waste analysis report. You must know what's in that material. Because if you get it from the city, they've got pine needles, they've got who knows, and they chew it all up and they compost it and you have no clue, and they're supposed to give you a waste analysis report. They won't, but they're supposed to, and they have it, but if you don't ask, they won't provide it. Yes?
Hi, John. If you're going to use your own leaves as compost, what do you have to do to make those leaves the most effective? Do you have to chop them up? Do you...
She and I have a history. Don't go there, yeah. I didn't see you back there. Take these two back there because they both had their hands up. Good question, because I use my residue on my property in my garden areas, landscape areas every year. Matter of fact, if I use all my kitchen stuff, what do you call that? Compactor in the sink? Disposal, garbage disposal. That got yanked out. All that stuff, eggshells, anything you can. And I don't have to fertilize any of these areas, never. The higher water holding capacity, higher nutrient availability. Your question was leaves, what can I do? Best thing to do is compost them. And if you don't want to do that, go through that. They will break down in terms of leaf size, smaller particle size as they get crinkly and you stir them up. Try to rotate a compost pile, but if you don't and you just spread them out into a landscape bed, then just remember that those leaves are very high carbon and low nitrogen, and as they begin to degrade at the soil, surface, plant leaf interface, those bacteria in that surface soil start chewing on those leaves, degrading those leaves. There's no there's no nitrogen in those leaves. And so those microbes that are doing that are going to take nitrogen from wherever they can get it at the expense of your landscape plants. So always throw a little nitrogen on mulched landscape beds if they're low carbon and nitrogen ratio, and that's what's one of the parameters that's on that waste analysis report. Now if you're using local leaves and all that, you don't take it to the lab and get an analysis done. But if it's deciduous leaves, they're not as acid forming as they are if they're pine materials. So be careful. And if sawdust is great, but it has so much carbon relative to nitrogen that you've got to add some nitrogen, otherwise the plant will be nitrogen stressed.
So if you purchase compost or whatever, so that, you know, and get it from someone,
Yes.
a company, then are they mandated that they
Yes.
give you a waste analysis?
Yes.
report?
Yes, it's on, if you buy it by the bag, it's on the back of the bag. You buy it by the truckload, they won't bring it, because the person that owns the business is not likely driving the truck. So they're not gonna give it to you, you gotta ask for it.
Yes, okay.
And there's, by law, they're supposed to have that. If they're selling it to you, if they're giving it to you, all bets are off. But if they're selling it to you, they're supposed to have a waste analysis report. Now, interpreting a waste analysis report, Ashley, is not a simple thing. But it's not as complex as you might think. It's just, I need to know what the C to N ratio is. The lower it is, the less I worry about nitrogen. Anything less than about 20, 25 to 1, carbon to nitrogen, it should be okay. But anything above that, there's not enough nitrogen in that leaves, in that material, to do its thing to make soil organic matter. Because the C to N ratio of soil organic matter is 10 to 1. 10 to 1. And I'm applying material that's 60 to 1, I'm short of N. And that can hurt your landscape plants or your garden or whatever you've done. So for example, if I put a couple inches of sawdust, I love sawdust, man, that's a lot of carbon. Couple inches and work that in, rotill it in my garden, oh, that's great. And plant corn, sweet corn, or whatever kind of corn you want, a non-legume, it'll come up nitrogen deficient, you won't have any ears.
Just want to confirm so I understood you. If I can let the leaves degrade in my flower beds, just add a little nitrogen?
Yes,
Okay.
yes. For example, you know, we use pine needles, longleaf pine needles, right? Those little big bales. Some communities ban those because of fire hazard, but some still allow that. Well, the C to N ratio of pine needles is a couple hundred to 1. And as they do degrade, they form more acids, it's more acidic. So you gotta watch the pH, you gotta lime more frequently, or add higher rates when you do lime if you have those kinds of, but the other thing is, you've got that thick bed of longleaf pine needles on my flower beds, and your pH goes down and your nitrogen goes down, you've got to fertilize those. I don't mean over-fertilize, you gotta throw a little nitrogen on it.
Is the pH change really that significant?
Yes, it can be. Yes, it can.
What?
The question was, is the pH change that significant?
I guess I've always told that, you know, pH is a logarithmic scale, so you need
Yeah,
a lot to change the pH of that.
it takes a lot, but if you continually use that longleaf pine needle as a mulch, then all you have to do is just kind of think through. Every year that starts to degrade on that soil surface, you're adding more acid.
How about cow manure? Or
Go to a Home Depot and buy a bag of composted cow manure, and it has a pretty low C to N ratio. Very low N content, like 1% N. I'll do this calculation later as we're going to see. This is what we're targeting. This is an artist's rendition of what life is in the soil like. That's what we want. We want diversity and a lot of activity. We get a lot of porosity, yes. Water goes in, no problem. Now, if I'm trying to go garden, I got these little guys in there. I don't like that, but as you know. But that's just kind of over the top. So the value of this compost, this raising the organic matter, what happens is it creates this property called aggregation. And what that is the organic waste compounds, the bacteria chew up the plant material, it has a waste stream, yes? And then some other organisms eat that waste, then there's a waste out of that, or 35 eatings and waste later, different organisms, I get lots of organic compounds and they act like a glue as they coat clay particles, and it sticks these clay particles together in what we call aggregates. And so the size of an aggregate is much, 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 much greater than the size of the individual clay particles. And when I have aggregation, it has bigger pores and lets water, more water to go through. Even though it's a clay soil, it's well aggregated and water moves through, roots move through, air moves in and out. Things are more alive and healthy. So that's the value of the organic matter. From just a water and nutrient perspective, not, we'll talk about nutrients. But here's a compacted soil with very poor aggregation, and there's good aggregation. So easy to see. All you do is take an area of your garden where plants don't grow very well, take that spade and dig down and see what's going on down there at 8, 10 inches. So again, I go to farm fields and there's the fence row, not a lot of tilling going on, and there's all the compaction and tilling and loss of organic matter, and you can clearly see the difference. This is in the middle of the field, and that's on the fence rows. So what does the aggregation do? I just mentioned increased aeration, infiltration, water holding capacity, rooting depth. This is all enhancing life in the soil, and that ultimately increases the native supply of nutrients. So I can depend less on purchased nutrients. So how do I get there? You need to apply massive amounts of carbon. Again, waste analysis report, so you don't have any toxin. There are people that apply municipal waste and there's stuff that's in there, I don't know what is the source, but it has high zinc, for example. And you're using this material over a decade because it's cheap or it's free, and before you know it, I've got elevated levels of zinc, and I got some plants that are too sensitive to high levels of zinc. And the answer to the problem is, well, stop using that waste product. Got to go somewhere else. So how do I add massive amounts of carbon? Well, maintain plant cover at all times. That's the rule. 365 days a year. No bare surface. And rotations that produce more biomass. That means fix more carbon, and anytime you have large fields, this doesn't obviously apply to raised beds, etc., but you got to limit soil loss. It's carbon balance. That's basically what you're doing. You're trying to increase the carbon input and decrease the carbon loss. And your organic matter will recover, but it takes a long time to do it. So we have had plots where we've gone no-till and changed rotation to more productive, higher residue producing crops. And after 10, 15, 20 years, the organic matter doubled in the surface inch. But down to the soil sample depth of 8 inches, it's hardly noticeable because it just takes a while for it to build up. And but don't despair. It's all positive. It's very important to keep moving that direction. So again, that's the philosophy. Keep the soil covered. So you're thinking, well, what do I do? I got nothing growing in there. Should I put, ryegrass? I don't know. There's some legumes you can buy and put in there. They're not going to grow very long. You're going to till those in or kill them or something, however you do it, however you want to do it, and then plant your target crop. If you're permanent landscaping beds, then your permanent crop is fixed, and you may not need to do that. Just mulch it. I'm sorry.
Can you discuss the advantages and disadvantages of tilling?
Tilling is a good practice. It brings in oxygen. It mixes in material a little deeper in the soil. So when my roots grow down, they've got a little bit more nutrients down a little deeper than otherwise. But if I'm tilling it with no mass of unit, heavy tractors, why then there's no compaction. It's the compaction part that degrades soil. And by the way, then if I'm on a slope, somebody likes to talk about steep soils. If I'm tilling on a slope, then I got that nice fluffy soil, and it readily moves downhill. And you don't want that.
But doesn't tilling kill all the good critters that are in the soil?
It does say something about that in the book, the disturbance of microbes.
let's be careful about that.
Okay.
We're gonna talk about this in a minute, later, after your break. What products can what residue and other things can I do to increase that carbon? And how does it influence the number and activity of microbes in my soil? I can buy a product, cost me $60 a gallon. And I'm supposed to put that gallon on a half an acre. And it says, well, you're adding 10 million microbes, or 10 billion. In a gram of soil, I have 10 billion. So you're having no effect whatsoever, zero. It's hard to change life in soil. Even if I oven dry it, I think you're killing everything. Take it out of the oven, let it warm, let it sit there, and before you know it, it's flourishing with all the microflora.
So tilling doesn't have the bad impact there.
Not on the microbes, not on the microbes. It does on soil structure.
Yeah.
Will it encourage carbon loss and reduce the net activity of all the microbial species that are in your soil? There are over 35,000 different ones. Yes, it will. That's a food source for them. So yes, you're reducing the food source. So it does reduce the activity, the quantity of life in the soil, but it's not like you killed your soil. It's not like that. It's too powerful a resource to do that kind of
I'm
damage.
just curious, so, the people who, no-tilling, when you till, do you release, like, trap CO2? Like, and how much is it? Like, is it significant?
When I stop tilling?
Like, when you till?
When I till, yes.
CO2.
Yes, you are oxidizing the carbon. Oh, yes. Very good question. Did you get a sticker? Very good question. We concerned a lot about burning a fossil fuel and contributing CO2 to the planet and the atmosphere, yes? Well, this has been going on for 10,000 years. We weren't burning fossil fuel, what were we doing? Cutting forests down, huge carbon sink in forests. You take the trees off, it's a massive release of carbon. Massive release of carbon. And so we've been doing that for 10,000 years, so there's a substantial increase in atmospheric CO2 before we started digging up coal and natural gas and oil and all that. That just exacerbated the problem. But you never hear that side of the debate. And we're not going to debate that today. Okay, so again, this organic matter, when you're mulching and you're composting and all that, all of these very favorable things happen. You can see them on your list. But there's organic matter, as we were pointing out, obviously greater improved structure, so root growth, I get more nutrient uptake by my roots because they're exploring more soil volume, etc. So keep all those in mind. I just want to point out some cover crop issues real quick, and then we'll take a break because I need to get to nutrients. This garden area with legume cover cropping. This is a bare area that's being cover cropped. There's some more. There's field corn with soybeans planted. I don't know if I'd use soybeans, but he did. There's carbon being imported, bales of straw. If it's free, that's fine. Just remember, it's very high carbon and nitrogen. As that starts to degrade, that's going to take nitrogen out of the soil. That's going to get to, you want to get to your target plant, then you're going to have to replace that. So, again, keep the soil covered 365 days a year if you want its health to go up. Growers that have compaction problems, there's this cover crop called tillage radish. Anybody hear that? If you got any compacted, I'm working with an agent, I think Alamance County, that they just got, extension got donated an old Kmart or some parking lot, and they're gonna take the 2-acre parking lot asphalt out and do gardens and so forth. Well, it's concrete. I mean, after they took the asphalt out, it's concrete. So you need 5 years of cover crop fibrous grass roots, that's ryegrass and so forth, and a bunch of tillage radishes. So once that radish dies, you left this big hole, and so water infiltrates greater and the life starts to come back and it starts to be productive again. So again, in your notes, you can see if I'm interested in a cover crop to supply in, well, I better put some legumes. You want to add a little in, then supply some legumes in a cover crop. This is for your gardens. This is not your landscaping beds and so forth. But again, rye and ryegrass, if you're on a slope, you got to have pretty dense fibrous roots to stabilize that slope. So again, compost and animal waste are absolutely important. I'm working with a lot of vineyard owners that are interested in all this. I think we need to take a break, yes? Okay, so we'll come back to this in a minute. There's a question back there. Good question. Yes. The question is that when you grow the cover crop, how do I get rid of that and get ready to plant? Well, you only have two options. Well, actually three options. You can figure out a way to crimp it. That means knock it over and break the stem and it'll die. Okay? You can herbicide it. Ooh, we don't like that, right? But it's an easy way to fix that. That's the easiest way. Or I can till it in. But tilling in fresh residue is a lot harder than dead residue. So tilling is not a trivial activity, especially if you let your cover crop grow really deep, really